study the context, the way that React updates with context. And yesterday I created these components and another page to see how it's gonna render. And I found out that, at least from what I have so far, it's different. But I'm not 100% sure if the way that I did here is like a good representation of what is happening when I use the reconciler on the other circumstance. So, but I think from what I've built here, it seems like it is the stuff that is happening is different on the two situations. When I'm using the reconciler from the React Pixie and when I'm doing like trying to mimic the same behavior with normal React, it seems that the way that the React does it is different, the way that it mounts and unmounts components, than the way that it is being done with the React Pixie. So I think it's likely that the problem is on the React Pixie library and the way that they decided to render the components, or the way that the reconciler is rendering the components, but I'm not 100% sure yet. So this is what I'm gonna investigate, and I'm gonna study React reconciler probably and React DOM today. The main thing that I wanna learn and understand more is how does React chooses to re-render components when there's a context involved. So let me go to the page that I have, that I made there. Is the theory page. So like the way that it's happening here, and the reason why I'm getting the error is because I should comment out of some console logs, but this is from another page. Let me see if yeah, so it first renders the main stage, which is the parent component, and the stage has it creates the root container on the reconciler for everything that is going to be happening inside of the canvas, and then as the children of this root, it has the canvas, which has the context. So the parent is the stage, and then it has the child, which is the thing that provides the context and the canvas. So it first renders the stage, then goes through the component it mounts, then gets the children, then resets the interaction, and then renders the stage again. And then after that, it mounts the Pixie component, which is the child of the stage. So it goes through the process here, and then after that, it mounts the stage component will mount here. And this is the issue because it's mounting the stage before it mounts the Pixie component, which makes it so that by the time that Pixie component is going to mount, the context was lost because the stage destroyed the context on the unmount. And then here it's going to unmount, then it fucks up here. So let me go to the other page. So I tried to mimic this, like the same behavior, but not using the reconciler and just using normal React components to understand like how is the cycle gonna be. And then here it seems like it mounts the child first, then it mounts the parent, and then it mounts the child, and then unmounts the parent. Then mounts the child again, mounts the parent. So in this situation, it's mounting and unmounting the child first, and then it mounts and unmounts the parent, which makes more sense because the child depends on the parent, but on the other situation is the other way around. So I want to investigate why this stuff is happening. And the thing is that I'm not 100% sure if the way that I did here is the correct way or not. So it could be like I don't have a 100% accurate representation of what's happening there, but I think it's a good enough approximation to highlight that it is different, the way that it's happening. And I assume that the reason why it's different is because the React Pixie is using the React reconciler. So there's some configuration that they made that makes it so that the rendering fucks up in the order. But it's very confusing because it seems like the previous version was working, and it seems like they didn't change that many things. So I don't understand how is it possible. It might be that the way that I'm implementing here is incorrect, but I didn't do any customization, I think, on the library itself. I just download the library and implemented it locally. So yeah. So I think I'm gonna put some music. I'm gonna do typing first, train typing for some time. Then I'll study this stuff. I think what I'm gonna do today is just study the way that React renders. I wanna study more how React works, and the very low level. I watched a bunch of lectures already. I'm gonna watch them again at some point, I think, today. And I'm gonna go through the source code and try to understand how it works. But as far as I understand now, it's just a function that keeps closure, which means you encapsulate everything under a function, and that makes it so that the variables are from the scope of the function, and that's what closure is. So it's like you're creating a namespace for everything that's gonna happen in React. So it's a immediately invoked function that keeps the closure for React, and then inside of the function you have other functions that create the rendering and do the parsing of the function component to functions that is going to be an object. The function component becomes an object, and then from the object it has functions and has props, children, and the type. So, and that's the part that I think that, yeah, React does that part, I think, and then the rendering part is the React DOM that handles, I think. And the rendering, it works on the work loop, which is just a while function, I think. It's a function that has a while loop and set timeout, and then through the loop, it checks to see if there's any component that has the state changed, and then uses the React fiber, which is a mechanism of updating the virtual DOM with the real DOM. And it works with lanes. So it's very complex from the functions I've seen, but I'm going to try to see if I can understand what is going on. And I might manually put the functions on Scala draw just to draw manually a graph of what is going on, so I can understand how the context updates the state of the application. Then once I understand that, I have to understand how the reconciler does. But now, at least, like, it's much better than before, now that I've done this, because now I have more confidence that the thing that is wrong, I think, like, my intuition was correct in the first place, where, like, the thing that is most likely wrong is the difference. Like, there's a difference in the way that the React reconciler is rendering when you use React Pixie, than when it renders normally when you're using React DOM. So the normal renderer. And that's the reason why it fucks up there, because it amounts in the correct order, in the incorrect order. So let me see, where did I put? I need to remove some console logs that I made here, so that is, so it doesn't have too many things there. Well, the other thing that I was gonna do, I think, was to, before I go back to studying the stuff, was to try to pass something as props, I think, to this child theory. Or maybe encapsulate the other thing, this thing, into another element. Because I think that the way that it is working on React Pixie is that the provider is a child of the main component, which is the app stage, where the functions is this class here. So this class creates the children, which has the app provider. So this is slightly different than the way that I'm doing here, because theory stage is the provider itself. So should be exactly the same. Would have to have one more level here, I think. But maybe it works in the same way, because this is a component. So this is the page. Then I'm putting the theory stage here, which is the provider. Then I'm passing this app here as a context, and then I'm using the app here. But the main thing was just just see the amount here. Because when I try to do it with the class, then it doesn't work because it's more complicated there. So I can try, maybe I can try, I don't know how to delete the, you search for this. Because it would be good to see if I can delete the object here and on the provider. Because here I'm making it to, no, maybe all I have to do is console log the app actually. So the app is the context that the parent is setting. And then here, actually, so I'll do like this. Because I want to see, like in the way that it's happening there, it should be no on the child. When the child is about to amount, it should be, the app should be no already. So that would make it so that you don't have access. Let's see if that happens here. Yeah, that's the thing. So child mounts, we have, then the parent mounts. This is another thing that I don't understand, because how is it possible that the child is mounting first, but it already has access to the app? So that must mean that the context is created before the first rendering. Otherwise, it wouldn't be possible for the child to have the context. But then, like, how does that work? Because you have to mount the component to create the context. So it's kind of, and this is the thing, like maybe I didn't do it in the 100% the correct way, like, or I'm not console logging the right points. Because on the other example, I'm using a class component, and this example, I'm using a function component. But as far as I understand, the function component, whatever you put inside of the useEffect is going to be the thing that happens when the component renders, and when you put what you put on the return function of the useEffect is going to be what happens when the component mounts. So here it mounts, then the parent mounts, and the child then mounts. So it is the correct order. So the parent mounts and now is no, and then the child mounts. Yeah, but that's weird as well. Because the parent unmounted here and became no. Then the child mounts and it still works. So is that possible? It should be no. And then is no here again. Yeah, there's some weird thing going on here. Because here it should be... Oh, it makes sense that is no. Let me see. Oh, maybe it makes sense because I'm initializing here. Wonder if I can do like this. Then I'm not sure if I'm gonna be able to pass here. Yeah, that's the thing. So first is undefined. Because so that's the thing. I think it initializes the parent first, but then it doesn't mount the parent. It's weird. I think it's the thing is I'm not capturing the rendering part. That's the thing. I'm just capturing the mounting and unmounting. So that's the difference between this console logs here and the other one. And that's the reason why it's showing up like this. I think that first it renders the parent, and then that's the reason why it has undefined here, because when it renders, it initializes here. Then it mounts the child, and then it's undefined, and then it mounts the parent, and it becomes the object. But it's weird that here is still undefined. It's obviously because it's getting the value outside of the use effect, but amounts, no, still undefined. Yeah, so I think the child always has the value that is outside of the use effect. So I think what's happening is that it sets the context on the render stage, and then regardless of what happens here with the mounting and the mounting of the parent, is always going to use that value that is set in the initially. That's the thing, I think. Because the thing is I'm not deleting the... I think that's the main difference, but it's hard to test because then I have to figure out a way to mimic the class, and I was having problems like replicating the class, the Pixie viewport class here. Because here the difference is that it destroys the app. It calls this destroy function, which removes everything from the class. Yeah, it does call these functions here. And the other difference is that this version is using event listeners, which might be different as well. The other one, I'm just console logging the value of the thing. So those are a couple of differences. Display objects. So it is removing the children here. Yeah, I think this is the difference. Because there I'm just when I'm mounting, I'm just changing the value of the context. But on the other situation is removing the children here. So like when you just change the value of the variable, maybe it doesn't matter because the child, the consumer of the provider is always going to use the same value that the provider had when it was initializing. But if you destroy it here, like if we remove the children here, it might fuck up there. But I think it wouldn't, because I think like this shows that at least like I don't have all the nuances because I'm not console logging all the parts of the cycle. And obviously I don't understand really well yet, but I think it is enough to show that the rendering, that the way that React renders is different than the way that the React Pixie is rendering, because it's using a custom reconciler. So a custom renderer which uses the React reconciler. So so I have to think about how I'm gonna study this stuff. I'm gonna look into the source code, I think, on the other thing. And I think I'm not gonna go to I'm not gonna put all, like, try to replicate this as close as possible, use the application and then destroy here. Maybe I'll do that in future, but I think for now it's better to just try to study the source code to understand how it changes the state. That's the main thing. So I'll be right back. So I'm just gonna study the source code, I think. I think the way that the hooks work is just a bunch of functions that the React API provides. So like the functions are done inside of the closure, React closure, and then the closure returns the functions as an object. And then all these functions that are related to the state, like they change the state. I guess it depends on the hook, but a lot of them change the state, and that causes the re-rendering. So I have to find what part of the React library handles that, so I can start with that one. Because the main thing that I want to understand here is how does the context change the state, and how it's going to trigger the re-rendering cycles. So I understand what are the functions that determine the hierarchy of importance of what components are going to be updated first. What's the logic that handles that? So that's the thing that I'm going to try to understand now. Once I understand that, then I can go back to your React reconciler and see if I can change the React Pixie library to work on the same way that React does, so that it doesn't fuck up the state there. And I think that's going to solve the Pixie view part thing. So like I'm gonna watch these videos again. They're very good, and I think on the other one he explains how the hooks work, and that's gonna be helpful. But the thing is that these videos don't show the files on React itself. It just explains like how it works, how React works, but it doesn't show on React. So I'm gonna have to search, to look for myself. Maybe there's something in the documentation that helps as well. I think it's unlikely. Because usually the documentation is more like on the concept level and not so much talking about the code. But I feel like I'm making a lot of progress and actually learning a lot as well, so it's very good. I think once I have this down, then it's gonna be like a lot easier to make updates, because I think this part in this beginning is the hardest part, to understand how everything works and set up the system. And once you have everything set up, then it becomes a lot easier, because it's just a lot easier to debug, and to like adding new features I think is a lot easier once you understand the fundamentals, because I already have everything set up. The most challenging part is setting up the events, I think. Setting up the event system and understand how to update the canvas and how does everything works when it comes to that. I want to see if I can find if they talk about where does the where is the actual source code for the functions.
Frightened of things that could happen, might not happen.
Documentation is actually very good, I think. But like, I don't expect the documentation to show the source code. That's usually not how it works, I think. It usually just explains the like overall concepts, but it's not gonna. Maybe it does show where the code is actually at in the project. That would be very helpful. I know it's because it's undefined. I'm doing the other way. I think it's not gonna change anything. Mounted provider. Oh, so it does change. But I think I deleted there. Yeah, I deleted here. So that's the thing, it's different because here it accesses the app that was created in the beginning So when it renders this component, it creates the value of the app and then passes the value. And then here it always has access to the same reference that started on the beginning. So even when I delete here, it's not going to use the deleted version, I think. Oh, when the parent amounts, or maybe no, because when the child unmounted here, it's deleted. So let's see if I don't delete, what's gonna happen. Hey, Boxland. Thanks, man. Also, maybe it does access the other one now? Because now I'm not deleting here, and then it is still an empty object. So the child mounts, the parent mounts, and then the child unmounts. Then when the parent unmounts, it makes the object, it deletes the key. And now when the child is mounting is the empty object. So it is accessing the updated version. So let me think. Yeah, but the thing is that the child can delete because it unmounts first. So it's not a problem. So it's different than the other one. And that's the thing.
Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing. Let's go dancing. I wanna go dancing with you all night dancing.
And this doesn't say anything about the context. Blah blah. maybe I don't think I tested sure just the thing is that it might take me to the declaration, the types. That's the problem. I wish someone that is more experienced made a video about like explaining why TypeScript is useful. Because I don't see the point so far. But everyone says that it is good, so it must like there must be good reasons to use it. I'm just not aware of it. But I think like I just don't see the point when trying to go to the place, like when I press F12 here to go to figure out how this works. I don't really see the point of going to the type, because like the type is not gonna tell me how the function works. Like it would be much better in the way that I'm thinking now, at least, to go to the function where the function is not the function definition of the type, like, but where the function, the source code of the function, so I can actually understand how the function works. And I don't understand why they do it like this. But there must be a way, must be a reason. The problem here with going through here is that is the version that happens after you transpile the code, so it's not the same. At least maybe I can have an idea of how it works here. Because the thing is, like, I have to figure out at what file and what folder this happens inside of the React there, so like I know how it works before it is transpiled. I'm gonna... And maybe it's very easy to go from here. So I think if I follow this path, I'm gonna be able to see... Like, I wanna find out where is the bridge between this and the React DOM. It's probably gonna be just... one of these files is gonna import the React DOM, and then inside of the function is gonna have a function that is part of the React DOM. So when it changes the state here, it's gonna call those functions, and then that's gonna be the bridge between React and React DOM, and then I can understand how it works, and then I can, based on the logic, I can see what is different on the custom React renderer, which uses the React reconciler and the React Pixie. So I'm gonna look at this version first, then I'll go to that one. This is interesting. I'm just gonna skim through this, then I'll go back. I have to think about a good approach to whenever, like, the thing is that hopefully I'm not gonna do this for a long time where I'm going manually. Hopefully I'm gonna be able to do, like, to create a parser to create the graph visualization. That's the goal, and then I won't have to manually go function by function. But at least for now, I should think about an approach that to be able to, like, navigate through this without losing like the direction I was going. Because here, for example, I want to investigate what this is, what value this is. Then I have to go to the value, but then I lose track of where I was in the file. I have to think about a good approach, not lose track of the direction that I'm going as I explore the values, these different values here. So, and here is, oh no, this is a different object. So the context provider uses this. I want to understand as well how does React takes the syntax of the component and translates that into a function. I assume that all it's doing is just getting the name of the component, which is going to be the same name of the function, and then based on that name, it just creates the object. And then if it has children, it's gonna parse that, and the children is gonna be the props. It's gonna be part of the props, and then inside of the props is gonna be like a hierarchy, which creates the tree, which is just a nested object. It's just defining a key. And doesn't show.
It's a place of the imagination.
Whatever. So when it creates the provider, it's because the way that you create is by putting the context and then dot provider. So you're passing the value of the provider. So the context is the object. When you create the context, it becomes an object. Then inside of the object, you have the provider, and that's how you create the component that is going to provide the value. So you access the value, and that is going to be the component, which is probably going to be an object, and then you pass as props the values that you want to pass in the context. So I think that at the end is going to be an object with values, and each value is going to be whatever you pass to the context. So the question is, like, why? How does it ensure that only the children have access to the context? I guess it's just because of the hierarchy of the tree. Like, intuitively, like, obviously, I understand how it works, but I have to think about how I'm gonna capture the connection there, because, like, that's the thing there. You go to a dead end because, like, is something else in the application that is making the values being it should be updated. Like, is the React DOM render that is creating the work loop that is updating everything. So that's the thing. Like, just by looking at the source code of the context there, it doesn't allow me to see what is happening when in the rendering cycle of React DOM. So I'm trying to get a clear picture in my mind of what's happening. When you create the context is an object, but then, like, and that object is inside of the hierarchy of the tree, which is also an object that has the type, the props, and the children. So the question is, on the rendering process, how does it keep track of the context? It has to do, obviously, with the hierarchy of the objects that are the DOM nodes. So I assume that on the rendering process, there's something related to this context object and the provider at some point. So I have to figure out how to find that. I think that, and that's the challenge. And probably on the other project it's gonna be easier to understand, because this is all in one file, so, and it's after the code is transpiled or compiled, however you want to say it. So this is the thing. So let me go back to use context. So create context creates the object that has the provider and the consumer, I think. So let me go back just to make sure. And this is going to be the object, and then provider and consumer, and then here initializes with the type of and the context. Type of is the thing for React that determines the type of the component that is going to be, and has a $sign to prevent the cross scripting attack, because then it doesn't, I think it doesn't, the $sign doesn't let you replicate or inject components, your custom components, through cross-site scripting, I think. I'm not 100% sure. And then the thing is, I don't understand why it creates this object here inside of this thing. Separate object but proxies back to the original. I'll put this stuff on ChatGPT and see what it says. Oh, so I understand. I roughly understand what's going on, but not that much. I get it intuitively, but not the specifics. I guess the question is, how does it access this proxy object here? Blah blah blah. So this is the old version, I assume, and define the properties here. So initialize with a different type of, and then, so this is React context type, React provider type, but this is on the context provider, not the context itself. Yeah, so React context type. So it's the same one here. The other interesting part is this part here, because I think this has to do with the problem there. And it's something that they talk about in the library, but I'm not really sure if it is related or not to specifically the problem I have there. Because I think the problem I have is more because of the rendering cycle that is not done in the best way, let's say. Like here, I think is something different, because it's when, like, the context for the app comes with the library, so I think it's different than, I think this context bridge that they talk about here is if you want to do a custom context that you initialize outside of the library and you want to pass as a inside of the child of the one of the child's component of the library. So once that happens, then you have to use this context bridge. But if you're using the context for the app, I think it's different. So it's not necessary to use the context bridge. I think the problem is because of the rendering cycle. Because otherwise, I wouldn't be able to access the app in the other components, in the world components and the mouse. So but I think it is related to this stuff here, and that's why it's interesting, because it's saying that to support concurrent renderers, it uses these two values here. So I assume that, but the thing is, the context is created through the custom renderer, so it should be isolated from the renderer outside, I think, but maybe not. I think I'll be right back. Fuck. There's too many mistakes. Yeah. Trash. I think there are several different patterns that I learned the wrong way. So like I automated the wrong process, let's say. And then even though like I feel like I'm gonna make a mistake, I still do it because it's like it became a habit, so I should correct those parts, go slower and focus more on accuracy. But sometimes it's just the keyboard that fucks up. That the key is stuck, so. Yeah. Yeah, they don't have anything about the rendering. guess I can try something as well. Just to see if it would work. Which is to destroy the app on the custom components. So call here. But the thing is, I think I talked about this last time at a stream, but it's not a very good solution, even if it works, I think. It doesn't feel like it is the correct way to do it. Oh yeah, because I don't have access to the thing. I guess it receives an instance, so... But that's gonna be the viewport. Not sure if the view has a... I think it does have a destroy function. Yeah, it does have destroy. So this does work. But it's not the best, I think. After I figure this stuff out, I'm gonna have to see how I can make it so that the nodes still have the events. I'll have to think about what is the best way to do that. The easiest is obviously to put the event listeners on inside of the elements themselves instead of putting the canvas. I think that would work, and maybe that's why it's not working, because when you put the pixie viewport, it overrides the events on the nodes because it's on top of them. But then if you put on the nodes themselves, it probably will work, but I'm not sure if that's the best way to do it or not. The issue with that is that you have to put on each one of them, but maybe that's the only way, because I guess it does make sense to put the event listeners on each one, because it makes sense that each one of them would have its own like control state, kind of like a cell in the body, where inside of each cell you have the mechanisms for handling state inside of the cell. I think programming is very similar to the way the body works, actually. And it's pretty much the same thing. You have the protocols of communication between the go from the blood, and then each cell has like the I don't know what the name of the wall is called. Maybe it's just wall. Then inside of the cell you have the mitochondria, I think. And yeah, I don't know much about it, but I think it's very similar the way that it works, probably. Like a cell is kind of like a function, like encapsulates the variables, let's say, and then you have data passing around between different cells, which is, it passes through the blood, and that makes, it updates the state of the body, which changes the computation of the body. Things very similar. Not sure if it's exactly the same, but it's hard to tell, but probably similar. the thing is that like this it would work as well because I'm not destroying here, but like the thing is that like it's a good enough solution, let's say, because it does make it so I think that it's gonna have the most recent version of the app, even though it's not synchronizing the right way, because the here is not destroying, but then because it's destroying here, it updates itself to the current one, I think, to use the most recent one, but I'm not really sure. It's probably not the best solution, I think. It's still like it would work like this as well, just because it works because I'm not destroying the app, but the main difference would be that if I destroy here, I think it attaches the event listener to the most recent one, because like it unmounts and then it mounts again right after. And then when it mounts again, it has the most recent version because yeah, but the thing is that in this way it's only gonna have one version so of the app, because it doesn't destroy after each cycle, so it's the same thing as not putting there, I think. But it might be better because it recycles the version of the Pixie viewports, but probably doesn't make a lot of difference. I don't know why this is being... It's console logging this. Right here, like when it mounts here, it's gonna destroy the... It doesn't destroy the app because it comments it all. But then here it would destroy the view, which is attached to the app, and then creates again. So I'm just gonna study the source code from here. I think is better. I hate when it does that. I think this is just creates a hash, a unique hash for each one. And that's the whole thing about the preventing cross-site scripting attack, so not that hard to understand this, I think. It's very similar, obviously, it's the same code. Text provider. It just creates an API so that it gets everything from the other ones for creating backwards compatibility. I think I understand. I just don't understand how it works, like in practice. Like how does it access this? The way that it works with the versions. Yeah, here is also tough, true, because it only has the function. It doesn't have the, doesn't show the connection of the function in the way that it's being used through the state. So I think what I have to do is just search for. Initially, I think the way that it works is that it's just gonna create the tree. So it's gonna append everything. It's gonna parse all the components, create all the functions, then creates the hierarchy, which is the nested object of functions, and then each level of the object is going to be a component that has the properties. So that's the first iteration, that it creates the virtual DOM based on the real DOM. And then I think after that it delegates the responsibility to the React DOM, which is going to handle the work loop, which activates Fiber to determine what's going to be updated. So I need to figure out where, at what points. I think like I'm going to start at the top again, and then I'm going to see if I can figure out like at what point the React library is going to call React DOM, how they're related to each other. Because I need to understand how these functions are used in the context of the state. The state updates. So this is the main file, makes sense. So dispatcher is probably like a similar paradigm from Redux, I think. The way that it works, like it creates a store and then the store manages the updates. and then the store receives actions and the dispatcher, which is the type and the action, I think. And then based on the switch cases, you're gonna determine what's gonna happen. So I think like this value here, it changes depending on the state of the application, and then depending on which state it is and which hook is being triggered is gonna do different things. But the thing, like, I don't understand really well how this works, because obviously it's calling recursively here, but here is calling the useContext on the dispatcher, which I don't know what value it is here. React reconciler. So here is probably one of the points, because it is using the reconciler, so it has to do with the management of the state. So that's one of the points of connection between the reactor and React DOM, I think. Source. React internal types. And also I have just set it to false. Hopefully this fixes, because this annoys me a lot. A thing where like I open a file and then it overrides the file that I had opened before, so then I have to manually find the file again. It's really annoying. So hopefully this fixes. Yeah, so what I want to understand is how... I guess I was looking into this now. What is this object gonna be at this point here? Once it calls this resolve dispatcher, and it gets the current dispatcher, what is gonna be the use context? Is it gonna be the same function here? And then it, like if it has, it doesn't make sense because it would create an infinite loop, but I think that this is gonna do is just gonna call this function based on the current context. But it's weird because like it would just call itself recursively forever. I don't understand how that works. As it doesn't, I don't have the file here. Oh, here. It is similar, I think, with the Redux pattern. It just creates a star. So I guess it's just the same value, but then it gets the current one, but it's kind of weird. I don't understand how it works really well. Because if all of this function does is just call the same function but on the current context, then how does it have access to the context? Because I assume like this is not gonna run 100% of the time, or and it doesn't return this value here anyway, so just using this should task, make this task here. Yeah, so whatever. trying to figure out if as I don't remember really well what is the function that is called first. I want to remember, because I know that when it calls React DOM, it uses React DOM.render, and then it passes the component, I think. The component and the root element, HTML element. And that's like the entry point for React DOM. That's gonna handle all the state, but I don't remember how, or maybe I'm not even sure if I saw, because in Next.js is already done for you when you use the commands before. But I remember like way back when I was doing the free code camp tutorials that I did from the beginning of creating the application using React, but I don't remember what command was I think was create element, but I'm not really sure. Because it has to be, it makes sense that it would be create element, because create element is the thing that transforms the component into the object with the properties. So I think that the first thing that it does is uses create element, and then from the initial component it passes that to the render. And then because everything is going to be a children of that component, then the create element is going to create a hierarchy of objects, which is going to be the tree, the virtual DOM. Yeah, I think that's how it works, but I don't remember really well, so I want to make sure that this is what's happening, because then I can go from the first function that it calls, because here there isn't any main function in this file, so like it's just exporting a bunch of things. So I want to remember how usually is done to create the application, so that way I can investigate the function first, which is probably going to be create element. Then from that I can follow the execution and then see how it's going to work with the React DOM render. To try to understand how everything is connected. So yeah, I want to get to the point where it's really clear in my mind how all of the logic that is responsible for mounting and unmounting all the components that are connected through the context. So that way I know like how React thinks about this, about what happens when you change the value of a context provider. When you delete the app, which is the context provider, how does React determines how to unmount the children and how to change their state before it destroys the app. So like before that it completely unmounts the parent component, which has the provider. Because once I fully understand that, then I can go back to the way that, then I can investigate the way that they did the React compiler, the custom renderer with React compiler, and then I can see like at what points, what functions they changed, and how does it change with the context, so that it makes the application break because of the rendering cycle here, this function. So I think that the main thing that changes from React DOM and from the custom renderer is the stuff you put on host config, which allows you to put different functions for the way that React is going to handle stuff. And it seems like it is a default property as well of React that the context is going to be viewed differently if you're using the parent host, let's say, the host renderer or a custom renderer. And that's going to affect the way that it updates the state as well. So I want to understand like the contrast of both, so I can change these functions here to see if it's going to fix the issue. Or if I have to fix I have to change the functions at this level here. So like instead of calling this update container, for example, on the Pixie Fiber, I call something else, or either I call this function and I pass a different argument here. So I have to understand how all of this stuff works. So let's see if I can find the function that initializes the application. This is really good. blah blah. Maybe it's good to read this stuff here. It's useful. Yeah, create root is the function. It's not create element. The root render. But create root is from the React DOM. So probably React DOM uses React to parse the elements. Interesting. Maybe you can just do that. It's simpler. Just put the command and look for the files. I think I'm gonna take a break now. I'm gonna go eat something, probably. I think I'm gonna remove the camera. And I'm gonna watch those videos as I eat something, and then I'll continue to study this stuff. Yeah, so what I'm gonna do is just figure out what is the entry point for the creating the application, and then I'm gonna investigate the function first. Try to understand how, at what point does it create the state and how does it create the work loop, and then try to understand how the use context is related to the work loop and how it's gonna decide what components it mounts and unmounts. And then, like, once I understand that really well, then I can go to study React Reconciler and see how can I change the code there in the best way possible to fix the library. So I'll be right back.
And this is why I needed Wi-Fi. I hope the Wi-Fi is good. If not, I'll like do a dance or something. You don't want to see that, believe me. All right, good. It's fine. You know, it feels to me, because I'm on stage, it feels to me like time is moving way faster than it actually is. The previous speaker could probably agree. Okay, good, it's done. So we will open. I just made this folder, so there's nothing here. We are starting from 0. Okay. I'm gonna yarn tsc in it. So I'm gonna just start up TypeScript, and so now I have this tsconfig file up here, and I'm just gonna tell it. Let's make this nice and big. I'm gonna tell it we have some JSX, and it's React we're using, and I'm going to, for this purpose, turn off all the strictness. I don't care. Don't do this in your apps at work. This is, yeah, exactly. But we'll just turn that off for now. And I will create 2 files. I need an index.html, of course, that my web server will serve, and this will take an index.tsx. So no magic, and here I will do index.tsx. So what we're gonna look at in this talk, 3 things: 3 React fundamentals, what makes React work. Number 1, the virtual DOM. Okay, we've heard this buzzword a lot. Virtual DOM, what is it? We're gonna look at that. Number 2, we're gonna look at hooks. It's the new hotness, how do hooks work, why do the rules apply. And number 3, concurrent mode, which isn't even released, but we're gonna kind of look at some, specifically one controversial decision that Facebook made, and we'll kind of dissect and talk about it. So let's start with the virtual DOM. Actually, we need to start one level even before. Let's start with JSX. So I'm gonna go ahead and serve this app. I'll do yarn parcel index.html. And this is gonna start up a little dev server. Okay, 1 second. Welcome to 2020. And I'll open this up, and we have a blank page. Woo! All right, I'm gonna take this blank page, put it here. And we're gonna be spending a lot of time side by side. So I'm loading index.tsx. Let's also open the console, get some console action, and make that nice and big for you. Okay. So const a equals div hello. You recognize this, right? This is React. This is JSX. But I have an error. React is not defined. Well, I didn't import React from React, of course. But we're not gonna do that. We're gonna make React. So I'll just do const React. You know what? Let React. That's right. I'm proud of it. Okay, so now React is defined. It's an object. Okay, but now React.createElement is not a function. So what we're learning here is this thing calls React.createElement. Okay, so cool. So now I just go ahead and create element. It's expecting it to be a function, so I'll just do that. Okay, no errors, but also nothing. So what does this function? What is this thing? What does this function expect? Let's see the arguments that this function expects. So I'm going to look at args here, and I will console.log. What are you? What are you? Oh, look at that. There's 3 arguments to this function. Div. Okay, so I guess it passes that. Null and hello. And I'm seeing here hello is children. So what could the second one be? Wow, you guys are so, and girls are so smart. Welcome to kindergarten. React. So we'll give it a class name. Okay, so we have the second one as props, and so forth. I've created an element. So what I need to do is I'm just console logging it though. So I'm not really creating anything. So if I go ahead and let's add some stuff. H1, hello, person, perons. And I will just add some lorem ipsum, nothing special. Great. Okay. Just have some text. And so I'm calling create element a bunch of times. And that's what we see here. And this one here, we see create element called on the root div. It's the only div. And there's there's like some undefined stuff. What's going on? Turns out children's and so we need to actually return something. We're just console logging args now. Let's return something and console log that. So create element. What does it do? I'm assuming it creates and returns an element. So const element is welcome to the future. So element is just going to be an object. Tag is I'm just going to change this to actually tag props children. Children is an array, so I'm just going to do that. And so tag props, but I want all the props, and I also want props.children to contain the children. Okay, great. And then of course I need to return it, but I want to also console log it. Return element. Bam. Great. It looks a little bit. We're actually seeing here our first React elements that have been created. I'm not interested in the children. I'm interested in the root one, the div. So what do we got? Div props class name 2020 children. I have 2 children, H1, and H1 has children, and so on. So what we're looking at here is what's the structure called? It's a tree. It's a tree. What else is a tree? The DOM is a tree. What we have here is the virtual DOM. The virtual DOM is just an object. It's an object with children. There's no magic. That's what it is. And so that's 1/3 of our talk already done. It's just here you go. Let's. Thank you. So we have, it's all good, but it's in console log, man. Like I'm not even, it's not on the screen. So next step, let's put it on the screen. But there's a flaw here because if I make this a little bit smaller, what you see is this isn't actually a React component. What is this? It's a React element. It's not a string, but nice try. It's a React element. What do I need to do to make it a component? It needs to be a function, exactly. So this now is a React component. Let's follow the convention. It's called app. Does it still work though? It doesn't. I have no console log because this is a function. We need to account for this case. So if type of tag equal, you know what? We're breaking all the rules today. Function. I will call it with props. Okay. And that, and I need to actually return that. Sorry. Need to what? That's right. I'll get there. Good. So basically, this is what they were saying. Very good. And so it works as expected. No problem. Everything's fine. But I need to put it on the screen. And this is where part B of React comes in, which is the renderer. So what we've just done is implement poor man's React. That's all it is. But React is just a part of the puzzle. You need to have something that takes your virtual DOM tree, puts it somewhere. Right? React Native does this for iOS, Android, whatever. React DOM does it for the browser. React Native DOM does it. There's a lot of different. There's React Inc that does this on the CLI. Just takes the React tree, puts it on there. So we need to create our render function. So let's just write the API first. Render that into document.query selector app. Alrighty. Render is not defined, of course. Import render. No, we're writing this. So I need to also have an app element here. So I'll just do this. And here's a pro tip for you. Any element in the DOM with an ID, the ID is also a global JavaScript variable. So you could do that if you really want to. Yeah, but let's just be purists about it. I'm going to get kicked out of this meetup and never come back ever again. That would never happen. Never stop. Okay, so we need to define render. So const render. Yeah, okay, we'll do const. And I will take a React element and a container. Okay, and I will render it. So what does rendering mean? In this case, I'm rendering to the DOM. So I need to map the virtual DOM element to the actual DOM. So I need to document.createElement. So that's what I'll do. Const actual DOM element equals document.createElement React element dot tag, because that's what we did up here. When we create the element, it has a tag property. Okay, so we're done. We next need to take the props, apply them on the actual DOM element, and we need to take the children and nest them. Right. So if React element dot props, if it even has props, because it's optional, then we'll take the keys of them. Dot keys React element dot props. We will filter them out for children. We'll deal with children separately. So P is not too many, not children. And then for each of them, we'll just apply them to our new actual DOM element. So we'll say actual DOM element P equals React element P. That's pretty much it. I need to do the same thing for children. So if React element dot props dot children, what do I want to do for children? Render recursively. So I will call for each of the children. So React element dot props dot children dot for each child. I will render, but this time the React element being rendered is the child into what container? This one, correct. So there we go, perfect. And then lastly, what's the final step? append the root to the container. So we will container dot append child's actual DOM element. Now this might fail because there's one case we have not yet accounted for, but let's see if this works. Yeah, it doesn't. It doesn't because cannot be property children of undefined. We're not only dealing with objects here. If you look at this tree, these are not React elements. They're just strings. They have children properties, they don't. They're string primitives. And so this thing can be either a React element or a string or a number. This is why we need TypeScript. So if this, actually, if string or number includes type of this thing, I need to treat these differently. So none of this magic here. Okay? I want to document.create text node, coerce it to a string, and put it in there. And I want to, actually, let's move this a little bit. That's fine. And so what I'll do here is container.append child. And I'll just return, I won't do anything else. So I don't know what, there we go, it's working. We have a render. We have a render. And this tree can be as deep as I want. I could even be like, here, let's just put an input field in there for fun. Input type is text, placeholder equals name. Okay, cool, save. Now I have input, placeholder, I don't know what's happening. I have a what? Oh, okay. What's the error? I mean, wait, line 32, what's my error? Thanks. Who said that? From your hand? You're the king. Round of applause, this guy. Good. So it's working. It's great. Everything's super. But our app's kind of useless. Because why? It has no state. It's just like, okay, great. You put stuff on. I could write this in HTML fast. And you come on. You're violating the code of conduct by thinking that. Kick them out. Anyway, no. State. We need state. Let's add state. That was the virtual DOM. That was the render. Let's talk hooks. Hooks are my jam. We need state. So let's go here. We're changing absolutely nothing except we're just being a little bit more verbose. So everything's gonna be fine. I don't want these warnings. How do I like? Yes. Filter. No, it's not filter. That one. No warning. There we go. I should also turn off errors and then my app would have no bug. Okay. So const. Let's do name because I don't like this person. It's very impersonal, right? So const name set name use state. No name by default, I guess. Person. Why not? And we'll go ahead and interpolate here name with a JSX expression. And what I want to do is value is name and on change e. Let's just set name e.target.value. Now something really interesting you need to notice. This is never going to work. Why? Because we're not the actual web platform specification for inputs is this. Okay, it's not this. This is React. This is web. So we're going to use the platform. Good. Let's see what happens. Oh no, use state is not defined. Of course. Yes, input. No, we will write it. Const use state. So let's think about how it works. I have my initial state in the argument, and then I return what? I return a tuple with the state and a setter. Simple. So initial state, so I'll just capture the initial state. So actually, we're going to mutate that. So state, initial state, and then set state, new state, state equals initial state. Kind of. You can tell I'm on the top of my game today. And then we'll return state and set state. Okay, looks okay. Not bad. Does it work? Kind of. Good. Does it update? Oh no, I'm such a bad coder. Okay, I quit. No, just kidding. Okay, so how do we make this work? Well, for one thing, we need to re-render, right? Because when you update state, re-render. So let's take our render function and let's add a re-render function to it. So what we'll do is we'll just copy this render. And this is poor man's React. It's not how you actually do it, but let's just do that again. What? Oh, arrow, right. Okay, good. But let's actually just try this. And then we'll call re-render when we call set state. So this is not just a reassignment, but we will also re-render. Is this going to work? But why not? What's wrong? State order. So now, but check this out. Oh, we have a append child. Okay, so with re-render, we'll clear the first child. We'll clear the root and re-add the root. Whatever. And this actually works. But what's going on here? Okay, so no, that's not true. What's happening is let's use console log to debug. Console log. Okay, use state called with initial state, and in set state console log, set state called with new state. All right, let's see what's happening. Use state called the person. Good, it mounted. Change person to Robin. It is changing it. So we're setting the state, but immediately remounting with the initial state. You don't see it. So we're starting to understand now how hooks work. How do we fix this? We use something that is very popular in JavaScript. Exactly. Yeah. Well, that is what? Closure. Exactly. So if you've ever done a JavaScript interview and somebody has asked you about closure and prototype inheritance, this is a prime example. React hooks works with closure. And closure, for those of you who aren't informed, is it's when a function's scope encloses over an inside function's scope. So we're going to assume that all of this actually is happening inside a module or a function or a closure. Every JavaScript module is a closure. Okay. So this file is no exception. So we will. Who said global state? You're right, but closure state. So it's not a window. It's inside this module. We will have state be this. And what we need here is some type of cursor because we have multiple moving parts of state. You know, how many times have you seen an app with just one state name, right? In fact, let's add this example. So we go to our JSX tree, and we'll add two pieces of state. Okay. The count is, and this is just a classic example. And we'll add some buttons, not blur buttons, on click. And we'll set count to count plus button, and count minus one. And of course, we need to call count set count use state 0. All right. So this is not going to do anything because it's the same problem. But now we have two moving parts of state. Cool. So we'll have our state in a store, in a universal kind of outside scope. We'll say const states, or yeah, we can say states equals this. And we need something to point to which state am I talking to right now. And so we'll just call it let state cursor equals 0. So every time we call use state, it's going to set a state in this array at index 0, at index 1, at index 2, and so on. These are the moving parts of our app. So if you think with me, when we call this, it's going to set index 0 to person. When we call this, it's going to set index 1 to our count, which is 0, and so forth. But we need to work with this. So we don't need the console logs anymore. We will freeze the state cursor here. So we'll say const frozen cursor equals state cursor. And what we want to do is just only work with that in here. This is where closure comes in. So we'll say state. We don't even need that actually. So we'll reassign states at the frozen cursor. Okay, and we'll return this one from the outer scope. Good. We just need to do one more thing, and that is increment the cursor to the next one. So when use state finishes, it says, okay, I'm done. Next piece of state. So what we'll do is plus plus. Exactly. That's why it's with let to. So state cursor plus plus. Does this work? Cannot be what? What did I do wrong? I missed TypeScript. Did I? Okay. Oh, so it doesn't like this. I think it was cache. Parcel has a really nasty cache. Console logs, as I called it. Everything. Oh, if I remove these. Just a second. All right. So we have this frozen cursor is the state cursor. Super. And we will just return states at. We need to also set the initial one. Frozen cursor equals initial state. Perfect. And then we will, and then we will reassign it here in set state, and we will return that. Good. Yeah, thanks. That's a really important one. State cursor. Let's break everything. Come on. Okay, good. It doesn't. I think it was just the cache. Let's go away. Okay, super. So now everything's fine. Does it work? It still doesn't work. And that's because on render, we need to reset the cursor. So when we render, all the cursors go to 0. We call set state, index 0, index 1, index 2, everything's set, and we reset it. So let's go back to that re-render here. Here, and we'll state cursor is back to 0. This, in theory, should work, but okay, but it doesn't. So, and this is where, I don't know why. I tried. Let console log states. Yeah, it totally works. But you see what's happening, we're resetting it. I call what again? That's right, so we need to read it's not always the initial state. Good call. So instead of initial state, it's either this one, if it exists, or the initial state. Perfect. And now everything is fine. Perfect. There we go. And so from this, you can see, so if we, every time we mutate state, let's just console log the global state to see what's going on. And so you can kind of see them updating here. And this is kind of the index that React has. This is a little bit behind because the way input works, but this is kind of how it works. And so if you have use state called 100 times, you just have an array with a lot of indices. But because of this, now can you kind of see why the rules of hooks apply? What's one of the rules of hooks? And no hooks and conditionals. You have to love them unconditionally. Thanks, Ryan Florence. So if let's actually just declare these variables here for the sake of demonstration. Nothing. Don't do this in production at all. But we let these be things. 0 and a function that does absolutely nothing. And instead of const, we'll just reassign them here. And we'll say if I don't know, like 50/50 math.random greater than 0.5, then we'll set this. If not, we won't, right? And watch our app be really weird. Okay. Nothing's happening. But let me change this. And so sometimes it works. And this is because on every render, this count either works or doesn't. So it's just a really confusing. Our luck is really not. Yeah. So if your app doesn't expect the way you should, this is. It shouldn't set count. Yeah. Yeah, it's just look at this. It's just really strange. Where does 380 even come from? It's octal. Okay, wow. Welcome to. But now it's 0. But at some point it's this, and so it's completely unpredictable. And this is why we look at this. This is why we have the rules of hooks. Thankfully, React will throw if you do that, so you're good. But that should help you understand. All right, we're done with 2/3. How are we doing on time? Do we have time to go concurrent? Or okay, cool. Just like whatever. Awesome. All right, we're gonna talk concurrent mode, and then we will eat pizza or do whatever we do. What? Oh, lightning talks. Stay for those. They're amazing. Cool. Concurrent mode. So for those of you who haven't heard of concurrent mode, it is async rendering. It's the way React is able to literally suspend. It stops rendering, waits for some side data to come in from somewhere, and then continues. The React team came under a lot of fire for the way they implemented it because people would say they abuse the JavaScript specification by throwing not errors but promises. And personally, I don't think it's abusing the language. I think it's creatively using the language. Nowhere does it say you can't throw whatever you want. I could throw the dice in JavaScript if you manage to do that. I could do whatever I want. So let's look at how that works. So let's assume. Let's go to my function. This app is my component, right? And I want to do something asynchronous here. Const. I'm going to use the classic example, even whatever. Dog photo URL. And I'll fetch from my favorite API. Breeds random. It's scary that I know that by heart. Serialize the response to JSON. And then I even know the payload. So the payload.message. Okay, great. What do you want, man? Can't find name payload. Dude, you're defined. Oh, it's a function. Got it. You see how I called it dude? All right, cool. Everything's good. It's 404ing, which means did I get it wrong? Yes, that's fine. I think it's random. It's image random. Yeah, that's the one. Wait. Yeah, I always swap them. Man, all right, this works. Image random. Perfect. Good. All right, so I'm fetching something, but nothing's happening. If I go down here and I try to, let's put it here. Let's do this and see what I see. Oh, look, there's nothing. Oh, I have a huge error. Cannot be probably children undefined. Oh my goodness, what's happening? Why? Can someone tell me why? It's a promise. It hasn't resolved. It says, hey, I'm going to go fetch data and come back whenever, but not now. And we don't. If you look here, we're not actually doing anything with promises. So good luck. So we need some way to wrap this promise and know when it's ready. And this is the first part of suspense for data fetching in concurrent mode. React exposes a primitive called create resource. It's a function that just wraps your promise. That's all it does. And the second argument is some type of key, a unique key, a name. So we'll call this dog photo. Okay. Now the error is create resources. We're getting a lot of not defines, but we define them, so it's all good. Const create resource. What do I want to do with this? It gets two things. It gets a promise and a key. Okay. So what I want to do with this is I want to check, has this promise been resolved? Is the data ready to be shown, or is it not yet ready? And then make a decision. So to know if the data is ready or not, I need some type of centralized cache. Again, closure, not global. So const promise cache, new, and it's just a map, nothing special. Okay. And what we'll do is we'll check if promise cache. If it has our key, we'll just return it. Promise cache.get key. Now, if it doesn't though, what do? We need some way from as deep as we are in the tree. We need some way to respond to this. So we can't just do like one level up. As you know with React apps, the component trees are deep, super deep. If you've inspected, you would have seen div, right? And so we need something to respond to that from the top. Now, this is how try catch works. You can throw an error anywhere and catch anywhere, and it just knows. This emulates a functional programming paradigm called algebraic effects, a way to respond to things deep inside globally. And so we're going to use try catch for that. To catch something though, we need to what? We need to do that. And we will throw the promise and its cache key. And so now let's save this. We have an uncaught dog photo. The next logical step is to catch it. Where do we catch it though? This is the question. You see where we're throwing in the app function. Where does the app function get called? No, wrong answer, but good try. It gets called in create element all the way at the beginning of the talk. If you weren't paying attention, boo-hoo now. But this is where it gets called. So we need to try catch this thing. So let's try to return that, sure. But we'll catch the promise cache key. And what do we want to do with this? We need to show something. The user needs to see something. So right off the bat, without even thinking, I'm going to return. Let's just do return div and props children. I am loading. And you know what? I'll return h1 because I want to shout it. Doesn't work. It doesn't work. Why? Props. That's not children is what? Props are children of 4. Oh, it needs to be an array. TypeScript. I miss you. Okay. There we go. I'm loading. We need to wait for loading to finish and then re-render. So promise.10 whenever it finishes. Data. We get data. Some data. We don't know what it is. And what we're going to do is set it in the promise cache. Dot set key to data, and I will re-render. And so now, promise.then is our function. Am I even throwing a promise? What am I throwing? Yeah, you're right. I'm not calling it. Correct. I need to call it. Let's go here and promise is thing that returns. So I don't know this late, man. There. You're right. Whoever said that, I love you. Thank you. Okay, good. Now we have perfect. We have the URL, but we're not showing it. So just to close this out, let's image this thing. Alt equals good boy. And just like that, we've implemented concurrent mode. It waits. Thank you. And so with that, we just implemented poor man's React, and we implemented 3 pillars on which poor man's React works. Let's just quickly talk some takeaways because this is literally poor man's React. Okay, it doesn't even come close. I mean, there's the whole topic of the reconciler, bread first algorithm that searches and detects changes and re-renders accordingly. We didn't even touch that, but that's not the purpose. The purpose was to learn. And I mean, this is a risky move. How many of you learned something new about React? Oh, that's the entire room. Okay, I've done my job. Good. And so let's just quickly talk some takeaways. Number 1, building is learning. I have so many conversations with people say, hey, should I build this thing? I mean, what if nobody uses it? Nobody's going to use my poor man's React. Okay, I just build it in front of you. Nobody's going to use it, but I don't care. I learned a ton. You learned a ton just from building this together. Building is nobody uses it. That's fine. It doesn't matter. I hope you get your validation from a better place. Number 2. Time is never wasted. I spent a lot of time kind of figuring this stuff out. And a lot of people say, okay, but what do you have to show for it? Well, I understand React better, but does that really get me richer? Probably not. Does it help my family? It doesn't. But I would still say this time wasn't wasted because I learned some stuff. And so the focus here is learning. And lastly, this all started when I was just like, man, do I qualify to be an engineer at Facebook? Do I think like an Abramov? You know what am I? Yeah. And so, it started with wonder. How does React actually? I tried to read the React source code. I don't get it. There's like secret Facebook internals don't use or you'll be fired or whatever. Like, I don't know. But I was wondering, and from wonder came this. I encourage you. Also, first speaker was wondering about migration. How is this working? And the wonder led to amazing products. And so I encourage you with that. Wake up, wonder. Doesn't matter if nobody uses it. You're not going to waste your time. It's going to be meaningful. With that, thank you very, very much.
Thank you for choosing my talk and coming to this room. You're all awesome. It's let's make them, like you said, jealous. The other room, right? I say performance, and you all say yay, right? So 1, 2, 3, performance, yay! Fantastic. All right. So this talk is mostly about performance, like making up much more faster, especially in React, and give our user better user experience. So how many of you actually have seen this page? How many of you actually have created a website or web application that causes this page? How many of you not have done that? But then what of the rest, though? What are you? Some people didn't raise the hand at all. All right, so we're going to talk about this. And you know that sometimes it happens, you see it and you click, and then suddenly some stuff doesn't work, and then suddenly they work like repeatedly, very fast. And that's the time where our user is very frustrated, especially including ourselves. So we're going to have today, we're going to explore different options today. We're going to talk about parallel computing versus concurrency. I know that the React also has a new experimental mode right now called concurrency mode. But this talk is you later can understand how they are implementing stuff. But this is mostly about new APIs in the browsers, like web workers. This is not new, but WebAssembly, worklets, and service worker. So what I'm trying to do in this talk is I just want to make it so practical. So I want you to go out after the talk and then open on your laptop and try to implement right away. No theory, no boring stuff. Just practical stuff and implementing code right away. So before that, let me introduce myself. My name is Majid. I'm flying from Oslo. I'm a passionate software developer, just like all of you. And in my spare time, I'm doing a lot of stuff. My hobby is running conferences, meetups, and leading the communities. It's very interesting to me. Also, I've written a book about progressive web app, but about our enemies, Angular. Don't worry. And I mostly talk about performance, PWA, progressive web apps, and Flutter. So let's get into that. What is parallel computing? When we are talking about parallel computing, we're talking about multiple entities that they are doing different tasks, or they're working on the same task. And compared to concurrency, when we are saying concurrency, that means we have one entity which is working on different tasks. Like these pictures are self-explanatory. So how does it work like in the browser? We all know that in the browser we have single-threaded JavaScript running in the main thread, right? Everything is only in one thread. And that's a bottleneck. And how it works, the way that it works is that we have event queue. We have a lot of events queuing in this lane, and then they executed, getting completed, and then go away, and the next one comes. So that's where the problem starts. When we have a long event happening, then everything is blocking because the event needs to get completed before we move on. But what kind of option we have to solve this problem? The first option is going to be web workers. So web workers are around for around maybe 10 years or so. How many of you know about web workers? Almost everyone, expected. How many of you use web worker? Less than 10%. And I'll show you why you don't use it, and hopefully after this presentation you're going to use it. So we know web workers that in browser they spin up another instance of JavaScript engine, and then you have a different thread and it runs everything there. And the way that they communicate with the main thread is via the messaging system, right? And this is how it works. So you have your browser event queue and you have your web worker message queue. You send your message to the web worker. It takes care of your events execution, and then once it's done, it can come back again to the main thread. All right. So but isn't it like this is the concurrency? So where is the parallelism? Well, different devices these days have different cores, like multi-cores, right? Nothing is stopped OS to run this thread in different cores, and that's when parallel comes in. That's when the parallel computation actually happens. But do we know that as a web developer? No, we don't know that, but it may happen. So let's get into some use cases for web workers. You can think of like very heavy computation in the browser. So you can hold up this heavy computation to your worker thread, get it to work, and then get the result back to the main thread. Like an example could be a very huge list that needs to be sorted. It's like blocking, right? If you use a for loop, it's blocking the main thread. So how it works, the way that it works is that you have main thread, you have worker thread. So you need to send a post message in code. That means after you instantiate your worker, web worker, you're gonna send the message to the worker, as like this example. And then once you send the message in a worker, you listen to the message event, you get the message, and react or execute the things that you need to do. Here's an example. And once it's done, you send back the message to the main thread. And the main thread, again, you need to listen to the worker message, which is coming, and then get the result, and then do something. For instance, set the state in React to re-render your UI. Okay, that's not very, very interesting. That's the reason 90% of this room doesn't use web workers. But can we do it better? Isn't it better, like, to get access to the function directly from main thread to the worker thread? That's way easier, right? Instead of having all of these post messaging around, just directly call the function in worker thread. Yes, it's possible. That's where Comlin's library comes in. A library from Surma, a Google web advocate, in which he actually created this library a few months back. So how it works? So in your main thread, you'll see that how this gets easy. In your main thread, you're going to have, again, you need to instantiate your worker, but this time you just use Comlink to proxy or wrap it. And once it's wrapped, then you get access to your object or function which you exposed in the worker, and then you can immediately call that function. If that's a promise-based function, you can await for that and then get the result. It looks like a synchronous way of programming, right? Way easy. So in a thread worker, let's imagine now that I have, by the way, you need to import this package for sure. So in the main thread, I'm going to have service and these different functions, which I'm exposing to the Comlink, from the Comlinks. All right, let's see in React how this could help one of our problems, for instance, in React application to make this move. So we had a use case that we had like a 3,000, an array with 3,000 members, which we needed to sort. And this is a very common use case, right? So it happens. There are multiple different approaches to fix the performance issue here. I'm just going to not to optimize everything and try to use just a web worker to see how it works. So what we did is that we just wrapped our worker, which has the function to sorting the list. And it looks like when I click in a button, I just call the function from worker and get the result, which is a sorted array back to the main thread. And my worker here is simply a function, just has 2 for loop. Like I said, we didn't optimize it. That is on purpose. So let's see actually how it works. You see, when I click on ascending with web worker, my animation for that little circle, it doesn't stop. And it works. But when I click the main thread to sort, then it blocks the UI. That means animation doesn't work. It stops, and then it works. All right. Was it easy? WebAssembly. Why WebAssembly? Because it's buzzword. No, that's serious. I have some question here. So when I say WebAssembly, just say it loud. No, no. When I say WebAssembly, what do you think? What is the first thing that comes to your mind? Say it loud. Rust. Wasm. Pineapple. Mozilla. C. Machine code. I didn't understand what you said. Yeah. All right, yeah, you're right. Or maybe you've heard like WebAssembly is fast. We'll look into that. Maybe it's not that fast. But let's see. Generally, WebAssembly, you know that. The purpose is that you write different languages in different languages, and then you compile it to assembly that can be run in browser, right? And when we talk about WebAssembly, well, the first languages that comes to mind is C, C++, and Rust, which they have a very good support for WebAssembly. So, but we as a JavaScript developer or web developer, let's say, maybe we are not very keen to deal with C or C++. I'm not saying that you cannot, we cannot, but that is not something we are used to, right? So maybe there should be a better way to deal with that. And maybe that's the reason we are not going to use WebAssembly. There is assembly script, where we as a JavaScript developer, if you know TypeScript, how many of you know TypeScript? Then all of you can use assembly script. So in assembly script actually compiles a strict type of TypeScript to WebAssembly. So there are strict types for WebAssembly, which needs to be only used in that assembly script, and then that can be compiled to WASM. So let's have a look. It makes it very easy for us to use assembly script. So how? First, when you set up your project for writing WebAssembly, you can literally download it from npm first of all, and then you can instantiate your or initialize your application, or create a new application, right? Then you get a bunch of folders and files, and everything is ready for you to write your WebAssembly code, your assembly script code. So here is where you can write your function. So you see here, it's a very simple function right now. I wrote a Fibonacci recursive version of Fibonacci to test like how performance is WebAssembly, and I wrote it in assembly script. So it's a very simple function, and you see that I am using some of the type that are not in TypeScript. These are the type that are dedicated to the assembly script, to the WebAssembly. So there are multiple other types too, which you need to get familiar with that. And luckily they are not that hard because we as a developer are familiar with most of them. You still need to deal with memory, maybe, in assembly script, but the way that you need to deal with memory in assembly script is very easy compared to C and C++ and other languages. And in the new, that's the news. The new version of WebAssembly, which browser vendors are working in the standard, there will be actually garbage collection, and that means we don't even need to do this later when it comes to the browser. So, and at the end, when you wrote your functions or all of the things that you need, or maybe some converter or everything, the only thing that you need to do is you need to compile your assembly script to WASM, just with one command line. It's just npm run as build. All right, so you get multiple files, and these files optimized are ready for production, and these are for debugging mode. So I have my WASM ready. Who has already worked with WASM? So, okay, you know that if you want to use WASM, if you want to instantiate WASM in the browser, there are some things that you need to do. And maybe it's not that interesting, or I'm not saying it's not easy, but it's boring stuff. But if you use assembly script, it makes it easy for us to fetch the WASM and expose it to the main thread here. So the only thing that we need to do is we need to import this function from this library loader, and then fetch your WASM and expose the services that you exposed from assembly script. In this case, I had my 2 function, which Fibonacci one is my interest. So I also wrote a JavaScript version of that function. Surprise, same function without type. So the same function. So I wanted to measure like what is the performance of the JavaScript version compared to the assembly script version, like WebAssembly version of that particular function for me. So I did a measurement here. So here is where I'll show you the measurement shortly. But here is where I say, when we say fast, we don't have to accept it right away. We need to measure first. Maybe for that particular case, it's not fast for you or for me or for that particular case. So I did a measurement here. That was a very simple function. And I thought that, okay, let's do that. For this number, I ran 2 functions. And it was fast for the first time. When I ran the WebAssembly version, it was 7 times faster for the first time. But for the second time, when I ran the function, then the execution time was fairly similar, like very similar. So here is where I actually ran this for the first time. You see the time here, and without WebAssembly, the time here is around 7 times slower without WebAssembly. All right, so you know TypeScript, you now know some types, then you can write some of your logics, and maybe some coder or something in assembly script now. And the third option is worklets. Who know what is worklets? Oh, good, almost no one. Worklets are a light version of web workers, so immediately comes to my mind, okay, they run a different thread, like a working thread, right? So that's good. And what it does, it just gives us an ability to access low level of rendering engine, like a graphic rendering engine, like CSS engine, or audio processing engine. That is very cool. So that means I can do many things. I can get access to the low level engine and then do some stuff. There are multiple different worklets available in the browser. We have paint, animation, layout, and audio. Okay. Except Paint, the rest doesn't have a very good support in browsers, but the Paint API support is much better. At least we can start playing with that and run some cool, heavy, like maybe animation in the browser. Let's look into that. When we say Paint, I'm talking about CSS Paint API, and that is also known as Houdini Paint worklet. So let's see how it works. Like web worker, you're gonna have a different JavaScript file. You write your function to draw something, to render, like paint something in the browser. Like in this case, I want to create a checkboard and actually render it behind my background page. All right, that's cool. So I registered my paint. This is a simple function here to create that. And then here in my application, I just said, okay, please add this function for rendering the background to my application. And then when it's instantiated, I can have paint function, add my checkboard function to it, and then I get a background image. I just write my background image in JavaScript. Let's see in practice. This is how it looks. So the rendering, this custom background image is happening in a different thread. It doesn't even block the main thread. So I'm sure now you get a lot of other ideas like how you can use this API. So another cool maybe example here, which I did in React, is to generate this QR code on the fly without blocking the main thread. So I'm actually rendering the QR code right away with Worklet, changing everything. It doesn't block the main thread at all because it's happening in a different thread. And as you see here, the animation is also always working. So that means my browser is ready for users to do whatever they want. And the last option, Service Worker. You may say, okay, Service Worker is not something dedicated to like main thread or maybe just React. Oh, yeah, you're right. Service Worker is a bit different from others. You cannot use Service Worker directly calling or communicating with main thread. Maybe you're right. But why I'm interested of Service Worker, I'm going to talk about it. Of course, I need to talk about it because I'm a PWA lover. So let's talk about it and see the use case of this Service Worker. I call this brain of PWA, progressive web apps. Who knows what is progressive web apps? Good, fantastic. The more I talk, the more I see that people know about progressive web apps, and the more they actually implement all of the functionality for that. That's awesome. So I have a full talk about Service Worker, which is linked here. You get the slides later, don't worry about it. So again, it's built on top of Web Worker. Okay, a type of Web Worker, but the difference is that Service Worker, as you may know or may not know, is like it acts like a proxy. Right? Okay, a proxy. It's interesting. What does that mean? That means the request and response can come to your Service Worker first, and then you can manipulate these responses or requests. But how can that help us to actually have some parallel computation? Okay, let's get into that. Let's imagine that we register Service Worker, we have already a Service Worker registered, and we have everything set up. All right. We can do some stuff on the fly because you can catch, respond, and request. Request, and then you can actually respond. So let's see here an example which a friend of mine did. So in this case, what was the scenario? You have, by the time that this example was made, there was only support of WebP in Chrome, and no other browsers, right? Who doesn't know what is WebP? WebP is another type of image compression, like JPEG, but maybe 30% more compressed, right? And also supports transparency, like PNG. They wanted to use actually WebP, all of their images, because it was way smaller in terms of size. Okay, great. But what about other browsers? Okay, one option was like to load different file for different browsers, right? But another option was, okay, let's intercept all of the requests and see if they are a WebP file. And he used some libraries, C libraries, and he wrote a function that decode those files, respond to the main thread, like respond to the application with encoded of these WebP. So the application could actually show the picture, even though browser didn't support WebP. That is cool. So in Service Worker, well, it also runs a different thread. That's good. So you can have WASM, do this stuff, and manipulate the response, and return the response to the main thread. The sample code and link to demonstrate is also added to the slides. Let's summarize it. There was some bottleneck with web workers, which we now realize that Conlink library can help us to make it easier to work with web workers. WebAssembly may not be easy to start working with C and Rust and those other languages. And if you don't have time to learn those languages, you already know TypeScript, you can start using AssemblyScript, Service Worker, and Worklets. There are also different running a different thread, which can help us to compute different scenarios for us. And that's it. Thank you very much for listening to me. If you have any questions, I'll be around to catch me, I'll answer.
As Robin so lovingly said, stages.
Hi everyone, I'm Swiss for Swiss.
This talk seems like it's gonna be really interesting. I'm gonna put a timer for 1.5 hours and then I'll take another break after. So the main entry point function is React DOM create root. So this is the stuff that I should be looking at. I just don't understand how it uses React. Maybe it's on here, could be here as well. I think it's this one, but create roots, container options. I should have waited to delete so I can look into the arguments again, but the thing is passing a component on that one. That's the thing. It's passing the component and the ID, the element ID. So maybe it's not this function. I think I'm gonna close the other functions. So yeah. So I have to start from the create root, and then I have to see at what point it's gonna use React to understand what the elements are, the components. I think I'm gonna have to create the thing again, so this time I'm not gonna delete. Let me see if it's still in the trash. Yeah. I'm just gonna restore. Because I'm pretty sure that it's passing the component first and then the element, the HTML element. So this is what I don't understand, because here it seems like it accepts the HTML element as the first argument and then options. So it may be not this function, it might be a function from another file. So it says client though, so React DOM and client. So I assume that it is from this file. It should be this. And that's the call here. Source slant React DOM. Yeah, it's it's this one. But this one's gonna use the React DOM. See? I think this is the function that I was looking at the last time that I did this. React DOM roots, yeah. So it is this file here. And it is that function, so this is the thing that I don't understand, I think. So how is it possible that it accepts the... Because this can be a component as well. But it seems like it is a HTML element that I should accept here. But it is passing only the roots. So the thing is, I'm confusing the rendering with the create root. So it uses this to create this object, and then it calls the render on this object. Okay. Yeah, so that makes more sense. So I'm gonna try to keep the focus on trying to understand how the context updates the state, so I don't get lost on all these functions. But it's gonna be hard, I think. This here is already branching off. So these are the options there that initializes in the beginning, I think. Maybe the beginning of the file. Yeah. Reconciler. Container, which is the main thing. What's the current container? So as far as I understand, the lanes are the things that determine the hierarchy of importance. So it's just numbers. So it seems it's not that complicated so far, I think. The thing is that it's never the issue is that it's never there that it is complicated. It's just that it is annoying to understand because you have to go back and forth between files. But usually, like, stuff is not that difficult to understand, I think. It becomes difficult because there's a bunch of things that are connected to each other, and then it's hard to clarify the connection of everything. That's what makes it hard, but it's always the same stuff, so like the same patterns, same stuff being used, so hopefully I'll be able to build this visualization thing, and then it's gonna like make it a lot easier to understand what is going on. So it just initializes the class in the beginning, which is the root node, and this is gonna be responsible for managing everything that happens, I think, on the tree. So this is still with the HTML element that is gonna mount everything. I don't remember if it was on this file or the other one. I think it was here. And this fiber is the roots. This container info. This is a container. Create container. That's the thing. Container. So just passing the HTML element to this, and this is gonna pass the HTML element here. So I wanna see what happens with So it should be this one. Yeah, it just initializes here. Let's see if there is it uses this any other place. No, it just initializes. I think the part that I'm more curious about is on the render, how it's gonna deal with the component, the JSX component, because I think that's where it has to use React to parse. And the way that I think it's gonna work is like, because the component that is on the render is going to be the top component, is going to be a massive object. So I think on the initialization, it just React parses everything, it transforms into the virtual DOM, which is a nested object, which is like the tree. And then from that point, it's gonna set up how it's gonna deal with the state, I think, based on this class here, because it already has all these properties. So depending on the way that the virtual DOM is gonna be, it's gonna decide how it's gonna change these lanes here to create the DOM based on the states and the hooks that exist on each component. But that's where it gets confusing, because how is the process of translating the virtual DOM, like figuring out where are the hooks? That's another point I think that's not very clear to me, is how, like, even though I watched the lectures, how are the hooks connected to the virtual DOM? Okay, so there's another function, maybe it's this one. Yeah, I think it's this one that I wanted to understand. Obviously, I'm not gonna worry about understanding every single thing, just gonna understand the superficial stuff first, and I wanna keep like the focus that I have of understanding how the context is gonna change the state.
The rhythm calls out to me.
So this is related to, probably uses this to map the work loop. Interesting. I feel like it's becoming more and more clear. It's understanding more and more. Because now I have a much better understanding of the way that everything works after watching the videos a bunch of times. So when I read through the code, I have a decent idea of like how everything is connected. Yeah, obviously still confusing. You know, I think over time it's gonna become easier and easier. Or maybe I should do some drawing with Draw to manually connect everything, so I can navigate later. Because here is already a problem. I already forgot where this comes from because I was investigating the other stuff. This is the issue. Oh, but I remember this, that the guy said on the video, created work in progress. This is one of the steps of the rendering cycle, where it's navigating through the tree and then calling this function to flag the elements, I think. And then the other one is begin work, and the other one is complete work, I think. So probably this is the file that handles all of this stuff. Go back. And so was this file, then this returns this, which creates a class. This one. So this ultimately is gonna return the class here. Oh, so I remember as well that the fiber updates based on the child and the sibling, like it is here. So as it navigates the tree, it flags everything until it gets to the bottom, and then it starts going up again. So this is one of the nodes. So I think this is what changed from like the way that it was in the past for the way that it is now. Before I used this stack, and now it uses this fiber node to update the components. I don't understand though, where is the current here? Because ultimately it's gonna return this thing, but maybe there's something along the way that I didn't see. Like what is this thing here? I don't understand why it puts the current. Oh, it's the current of the root and makes it push this. So the root current is gonna be a fiber node. I'm confusing the things. This is the fiber, so this is what like creating the tree, I think. It creates the root nodes and then makes the current equals the initialized fiber node, which is a fiber node. And then state node is gonna be root. Because it starts at the top, it obviously starts at the root. So I think this is the thing that is going to change as it traverses the thing. Like the root is always going to be the root, but then this one is going to like go across the tree and change the state based on what root is at, what point is at, I think. This is the one that current, so it's just initializing here, but I don't know. I assume that is the stuff that I talked about, where it's just gonna be the current node that is being analyzed, let's say. So it changes, starts at the initialized fiber node, and then as it traverses, it probably changes. So it creates this, which is the fiber node. It's just no in the beginning. Interesting. Pause. Okay. Hydration is just a process of activating the JavaScript, I think. So it first loads the HTML, then it adds the functionality by initializing JavaScript. But I don't understand really well how it works under the hood. Or what does it mean to make the JavaScript work? I guess it's just like, it's something to do with the engine, I think. Should be that. But I don't understand how this process works really well. Maybe I should search for this and watch later.
Unexpected things are beautiful.
Yeah, so it is React that adds the events handlers. I'm gonna do some typing. I'll try to go slow and focus on accuracy. Fuck, I started really strong and then fucked it up there.
Unexpected things are beautiful. You probably didn't expect to get.
Fuck.
Unexpected things are beautiful.
One thing that I don't get it here is why, like, maybe actually, like now that I think about it, I was gonna say, why do they like make this function and could you return this function here? So like, why not call this function directly instead of calling this one? But it might be because this one is used on, but it's still like, it doesn't make a lot of sense. Like, I mean, maybe it's because of these arguments here, but then why not make them? Yeah, I don't understand really well. Like, you could just pass the arguments here. So why call this function here? Why not call this function directly? Don't understand. The only thing that this one is doing is initializing these variables here. Maybe it's because of the scope. Yeah, I don't know. Could be something like that. Yeah, I think that's the only explanation that I can think of now. And so I think I understand what this function does now. Can I remember where this is being used? I think it's just the first function. A create container is gonna be, yeah, the root here instead of this one. Also, something that I didn't think about before is that, like, it's possible to create a website that uses multiple different versions of React, like, because you can mount this at any point you want, because you can get create several different divs, and then each one is going to be a root of one React. So you could have a situation where you have multiple different ones. But then I don't know how that would work. I guess it would work because then React would be responsible for only handling the states on one of them. And then if you want to nest them together, like, it would have to be in separate levels, but if you want to nest them together, then use the React reconciler to create different renderers. Which is the situation that I have there with React Pixie. But it should also be possible to create, like, completely different React render, completely different React entry points, and maybe you can merge different frameworks as well. I don't know why you would do that, but it's like it sounds kind of interesting. Let's say you build an application with Svelte, and then at some point in the application you mount React to handle the state on. But I don't know how that would work, like if it would work or not. I guess it would depend on the other framework, how you would deal with the state of the. Yeah, I'm not sure if it would be useful to do that or not. So I guess the render function has to be this one. Not sure. That's the only place that is initializing. The other one, like the create root, is gonna return the fiber node, which is this class. This is the root fiber node. Don't remember if this is the one or not. I think it is this one. Yeah, it's this one. So it's gonna return this class and it's gonna encapsulate this class into the other function. So when it calls the render method, I think it's calling on the prototype. Oh, this one. This is the function that it's calling. And it does react on our root.render. It should be this function, but then like why does this accept? Node list should run. Or react node list. Because this should be the component, I think. It should accept 2 arguments, the render, so maybe this is not this one. But if it's not this one, then I don't understand. Yeah, it has to be that one, because it's the only thing that makes sense. Because the class doesn't have a function, so like at the end of the day, it's gonna return the fiber node, and that's gonna become the root, and then it's gonna call the render on the root. So it has to be that function on the prototype. This one. But then I don't understand why this is argument here. Like, how is it possible that this becomes children? Don't understand. Because I don't understand how importing React here is gonna make React transpile this before it's passed into the function as an argument. Like, it doesn't make sense to me. So what would make more sense to me is that inside of the function there's something that calls React, and then it transpiles everything, and then from that it does the rest of the logic. So I don't understand how this works. But it seems like it is that function, because this one I'm just following the library there, so like the path. I guess the type might help if I go on this one. Maybe not. Yeah, because this is the thing, where can I find this function? Maybe I should ask ChatGPT. I think I'll be right back. So this is the thing. I think after it transpiles, like Babel is the thing that transforms. That's the thing. So it just takes that code and then based on the syntax, it's gonna make a bunch of React create element calls. Like, I think it's gonna like parse the whole application based on the syntax and the chain of connections of children based on the components, and then from all of that, it's gonna create a bunch of React.create element calls, and then that's gonna be the thing that is passed to React DOM. That's the reason why it's kind of confusing to understand, because if you're just looking at the code, it seems like it is passing the component, and then React DOM understands what the component is, like what this syntax means, because this is obviously JSX. So how does it go from this stuff to the children? That's the question. I forgot where is the function. I should be on render as this one. So how does it go from that component into becoming a React node list? That's the thing. So it's Babel that does the translation apparently. So Babel creates a bunch of React create element calls, and that creates the virtual DOM, and then that's... I think that the DOM itself is not passed here. In the beginning stage, it just creates a list of all of the components. I guess I can look into the types if there's... It's probably there. I'm gonna have to go manually because this doesn't have the context of the application, so it doesn't find the file, I think. So React node list, share React types. But if this returns a React element, then how does React DOM accept like children list or React node list? Doesn't make sense. So this is when you have several different elements, I think, instead of the children. The props is the object that is gonna carry the information from one component to the other one. So the name is children, and that's why you can pass this name on components to render the children. And this is populating the child array with the child arguments because it skips true because of the first true. I think type config, type and config. Let's create this array with the thing. Don't remember what object freeze does. I remember seeing this just like looking at the definition, I think yesterday, but I don't remember really well. Prevents extensions. So it makes the object immutable, I think. Okay. So pops children becomes the array. I think, if not mistaken, is the same thing that I've seen just now. First, another part of the code that I don't remember. It has something to do with the root there. I think it uses the same thing. Maybe it's like the same pattern but a different name. Yeah, I think that's the case. Oh, it's something about the context, I think. I was looking at. No, it is when it initializes the fiber. No, the thing. Yeah. I don't remember really well. So it is actually just React nodes. It's not necessarily a list, but it is like confusing because of the name here. Don't understand why this name. Maybe you can accept a list, but it also accepts an element. This is gonna be the one that was set in the beginning, yeah, here. Which is gonna be the fiber node, I think. Or fiber root. So this here is this. Where is it? Is this one? Yeah, this one. Root container info, which is the container, the HTML element, the beginning. So this would be the root div container. No type coming out. Not current. The current is the initial fiber node that it creates there. I think the uninitialized fiber, if I remember correctly. Yeah, this one. So root currents. This is the first one. Initialize the state of this as the root. Which creates the node. What is the difference between this one and the other one? Or this one, this. What? Where is it? Yeah, here. So what is the difference between them? This receives a container, this doesn't. Pending prompts, key, tag, hydrate. I think like it's a similar pattern from the stuff that I was doing with the poker tree node, where you have like one that is the main node and the other one is like the state of each node. This one is the state of the whole thing, let's say. The state of the... This has more information because it encapsulates the state of the whole tree, and this one just the state of each node. This class is going to be updated as the React DOM updates the state. Yeah, so this is the container, which is the DOM, the root div, this passing the current, which is the fiber root node, should this thing here, which is the host instance. So React fiber reconciler. Yeah, this is where it starts getting confusing because there's a bunch of functions again. So I guess I'll go back, then I'll go back again. Because I just want to see, like, based on the names of the variables, it's pretty intuitive what's happening. It's creating the instance of the host based on the current, which is the current fiber node, which is the root node of the fiber. So I guess I won't look into the other functions because the main focus is to understand the state. So I guess that this is the function that is gonna be like is the first time like it is gonna render. So this is called when it's mounting the first time the root fiber node. So it's gonna pass that root, which is the class there, and it's gonna pass the children, which is the child, so the first element that is passed. In this case would be this stuff here, which would be an object created with React create element. So it's just a nested object. Those types, type, props, and children, or type, config, and children, and then creates the props inside of the function call. So this is the first function I think that is going to start to render and hydrate everything. React fiber reconciler is this one. This is the fiber node there, the class. I think I'm gonna, yeah, this is the one. So this one is here, is the current of this one, which I think it is the uninitialized fiber node there in the beginning. So this is gonna be the current node, current fiber node. Which I forgot what it is. I think, yeah, is on this, is this one. It's gonna be an instance of this, the current here.
That's the real enemy. So, get it.
Don't remember really well what the bit shift, or I don't know how to say that, the bit operation and bit operation does. Like I understand that it's gonna make either be 0 or 1. Like it's like masking them, like overlapping them, but I don't understand. It's like kind of hard to understand what exactly it does, like on the concept level, let's say. It's just it makes all the bits be 0 when they're different, and then be 1 when they're the same. So, but I don't know what that represents.
I came to realize it's that fear that's the worst of it. That's the real enemy. So, get up.
So I guess it's just checking to see if the mode is concurrent mode, because concurrent modes only has, like, the way that it maps the modes is based on the where it puts the one here. So if that is true, then it means that then it means that it is concurrent mode. And I think I understand now. So because this is 0, if it is true, it means that it isn't, because then it would be 1, the bitwise AND operation. So this is only going to be 1 if the mode is 1, exactly at the same spot that the concurrent mode is. And that's going to make it different than no mode. So if this is true, that means that it is no mode. Interesting. And then if it isn't, it means that it's concurrent. I don't understand how this is possible though. Like, I guess I don't understand what this means. If this doesn't have a definition here. But like, I understand based on the concept, like the concept level, based on the name, I obviously understand. This means that it's gonna be, the updates are gonna be synchronous. If you don't have the concurrent mode set to 1, the mode set to the concurrent mode, it's gonna be no mode, and it's gonna make it synchronous, and then otherwise it's gonna be concurrent. But I don't understand how exactly this syntax works. Just a number. I guess this is a clever way to check if they are different or equal. I never thought about it like that. Like, maybe I'll start using that more. It seems like it is... Like, at first thoughts, it seems like, why would they do this? Because it seems like it makes the code more complicated and difficult to read. But then I think it's because of the nature of JavaScript, where like it opens up more space for error if you put conditions, I think, to check if they are equal or not. But I'm not really sure about it. So like, why use the AND operator and not use the equality here as well? But I think it's also because there are several different options, and this is probably used somewhere else. So like it's just an efficient way to compare different modes, to select which modes it is. I see. So, yeah, I need to spend a lot more time studying this because this is the key of the issue here. So the way that React works is through the lanes, and the lanes are going to determine the priority of updates, which probably is going to determine what things got mounted and unmounted first. And that's the main difference, I think, between the custom renderer and the React renderer. And the reason that I'm getting the error that I'm getting there. So I have to spend a lot more time understanding these functions. It's still like difficult to know how does the context is gonna relate to this. How does the useContext hook is gonna relate to this stuff? Because based on the code, there's kind of difficult to see the link.
frightened of things that could happen. Might happen, might not happen.
The thing is that this, like, it doesn't give me clues on how the hooks change the state, because like there's no connection between the lanes here. Obviously there's a connection, but there's no direct connection between, from the way that I'm looking here, from these lanes and the hooks. It's just setting up the updates on the like initial render, and at least I can't see like the connection. Yeah, it's passing the children the route here, but it's actually because I'm just on the beginning. Forgot. It's probably here that the connection happens. In the beginning it's gonna be no here, so it's probably no context. Yeah, so it's gonna be this one. So that's why I thought that, because I forgot that I wasn't at the end of this main function. I got deep into this one, and then I ended up forgetting that. I confused this one for this one. So maybe these other functions are gonna tell me something about the... So as far as I understand, this one just gets the lane for the first rendering. And then inside of this function there's a bunch of other functions that check to see what is the lane. What is the current lane. Like based on the priorities. And then there's a bunch of bitwise operations that determine which lane is gonna be in priority. So they're probably updated across the state of the... across the rendering cycle. So I think that's how it works. React uses the lanes to keep track of what's more important, and then based on that it decides what's gonna update first. don't understand how that can be like this comment here, because it's gonna be no when it initializes. So, and it's the first time that it's mounting the thing, so I don't know how it's gonna be any different than no in the beginning, because there's nothing that changed the value there of this thing. That doesn't make a lot of sense to me. Because the current is the fiber node, which is a class there. So, and along the way of all these functions calls, like nothing changes the value of the thing there. The updating queue. So how is it possible that it's gonna be different than no? Oh, that's I'm looking at the wrong one. But I think it should be the node there. Because that's the current one of this one. Update queue. Yeah. So how is it possible that this is not no in the beginning? Doesn't make any sense. Must be missing something. Because this is gonna be the fiber. Then this is gonna be no. It's just gonna return no. But the component is not unmounted, it's just being mounted. So, don't understand. And then when this returns, it's just gonna stop the function here, so I don't understand how this would make it so that everything works in the beginning. Like, it doesn't make sense to me. There's a lot of stuff missing. It's hard to know, to understand the connection between the things. It's not explicit in the code here, I think. Like, there's probably stuff that is invisible, like ChatGPT said, the Babel translation thing. That's the issue. It's like bridging the gap of what's invisible through the source code here. This is also weird because on the internals there's no transition inside of that object, so I don't know how they do this. Like the variable that it says that don't use this or you'll be fired or something like that. I don't know how that works. Like maybe it's something like a .env file, but like, yeah, I have no idea how it works.
I'm in charge here.
What the fuck? I don't understand this. I think I understand. So when the event's not caused inside of the React, it's gonna ask the host file, but then I don't understand how that works. Like, it creates that file just so that the error doesn't go silent, but like, it's probably something to do with Babel or some other tool like that. That figures it out what is the event. Problem is that here is always gonna be no. I don't know how this is not no in the beginning. So maybe it's something that I missed when I was looking into the functions that initialize the fiber node. It must be that. Maybe it's this instead of here. Looks like they probably disabled the stream. That now I understand. I think every time that this happens is when they disable the stream. That's why I get these warnings every now and then. Probably because of copyright. Yeah, I think I'm gonna. This is a good point to stop here because I'm already approaching 5 hours and a half. So I think I'm gonna continue to study this tomorrow. Like, there's a lot to understand yet. Like that's the thing. But I don't think it's worth to continue on the project until I understand with this really well. I really wanna like know very well intuitively how it works and what is happening when I change the value of the context, what's happening with the lanes, and how it's gonna determine what's gonna be updated first. And then only then I'm gonna look at the React reconciler. And looking into the React reconciler, I'm gonna try to understand what is the difference and why is the order when I'm using the React reconciler with React Pixie, why is the order different than when I do with the normal components? And if there's anything that I can change on the configuration of the host or when calling the methods in the cycle of mounting and unmounting. So that's the stuff that I wanna understand. And it's gonna take a long time, I think. But tomorrow I'm probably gonna start from this point that I'm at. I wanna understand because I think I might have to go back because I don't understand at what point does the current value of the fiber node becomes the enqueue update becomes different than null. Because as far as I understand now, it's gonna be null there because when it initializes as null. So, and if it is null, then it doesn't make sense here because this would be null when it mounts the first time, which means it would only return the lane, and then there is no connection between the rendering and the other stuff. So it's obviously not null here in the beginning. It should be something different because it's gonna call these functions. And it looks like inside of these functions there, as far as I looked into it now, it seems like those are the functions that determine how the update's gonna work, because it looks like they are doing the work loop there. They're just gonna update all of the elements. And obviously here is more complex. And the other difficult thing is that like the transition between the component and the object, the React object, is not very clear. So I don't understand how the children are connected with the main thing. But I guess it's based on the fiber node here, this current fiber node. It all goes back to this, which is the initial state, initial fiber nodes that is going to be updated when the root node is mounted. So it's understanding this, at what point it changes the value. So I'm probably gonna have to go back and forth a lot of times until I understand the connection between them. Of how this one is keeping track of the... And I guess it's probably through this memoized thing, memoized state and the state node. So Like this handles the state with the lanes. The lanes determine which much is gonna be, what functions are gonna be called. So what things are gonna have priority over others. But I have to see at what point does this values here change for this fiber node when it's creating the thing. In queue update. The problem is that so many files that you lose track of which ones were in the beginning there. I think this is the one, first one. And then the render is this one. But I have to see the create root first, I think. Go back to this one and see how does, if at any point it changes the value of the current enqueue update. I wanna see, let me react down. So here, react down, react down. I wanna see specifically if this value is changed. Yeah, there isn't anything about this. So maybe here. This is the thing that is weird. And it only changes the state now in the beginning. That's why it doesn't make sense. Or maybe it's this one that I didn't look into. Oh, that's why. So, okay, so I missed this one. Now it makes a lot more sense. So in the beginning it's not gonna be no, it's gonna be this object here. Yeah, that makes a lot more sense. So now I can go back to the other one and see. But I think I'm gonna do this next time or tomorrow. So I'm gonna go back. I need to keep track of these files. There's so much stuff happening. This is the one. So I need to keep this one, React Fiber class update queue, with the other one that I forgot already. I think, let's see, updates. I think it's this one. Blah, blah, blah. Yeah, here. So this one. This one. Yeah, so on this is not gonna be no. So I have to see this function while keeping this object in mind. Oh, where is the... Fuck. Did it close the file? Oh, it's on the same file, I think. That's why. And that's why it's confusing, is because the same file handles the functions, but yeah, this one initializes, so it's gonna be this object that is gonna use. I'm gonna copy this stuff here. I even wrote down here. And then this function is probably gonna do something. So shared, let's see. That's gonna be this object pending lanes. So I think that the key is gonna be these functions here. This is the one that is gonna do the initial update, and then this makes the transition. And here's probably where I'm gonna understand more the bridge between the fiber and the hooks in React and how. Yeah, but we'll see if I'm gonna be able to understand this. I think I'm gonna watch the videos off stream as well again to remind on the concept level how it works with the hooks, and then tomorrow I'll study this code again. So see you then.